Hi everyone. My name is Santosh Sarait. Thank you, Eric. Thanks for the quick introduction. I would like to take it on from here, starting my presentation. So before I get into the details, I would like to take a few moments to introduce the team who are heavily involved in locating these underground utilities. Starting with Del Dot team, again, Eric Simo. Thank you very much, Eric, for giving us an opportunity to demonstrate this new technology to accurately locate the underground utilities and make sure during the bridge replacement project there are no damages happens to these utilities, which is will be very expensive. And again, we appreciate your proactive approach using the advanced technologies and trying to get more accurate and reliable data of these underground utilities. And Chuck, thank you again, Chuck. Thanks for your leadership here, for bringing all the parties together and coordinating with multiple groups of people and making sure that we are meeting the requirements. Again, I repeat here, the success of this project is mainly because of the two key factors. One is the collaboration and communication. And I really see that was very much given the high importance in this project to get this project done on time. So the next thing is the utility owners, both Sussex County and Artesian Water Utilities. Thank you very much for your collaboration with Infomap and us. I would like to thank Wayne for all his support all through this project, and also Mark from Sussex County for his support providing some preliminary information before we get into the field. And Infomap was very key partner here. They were trying to collaborate with the traffic regulations, and more importantly, they are a subsurface utility engineering team using the utility investigation tools for accurately locating the utilities. And finally, last but not least, Prisum Technologies. Myself, Santosh Sarai. I'm the Vice President for Strategy and Business Development at Prisum Technologies. I'll be going more the technical details on this project, and handing over to the other presenters today. So just to give a quick glance about, let me, yep. Today's presentation, I'll be focusing mainly on the Prism technological solutions. It's called as a Gyro mapping system, which will be utilized to locate the underground utilities. I'll try to explain what the value that brings back to the industry. Again, there are multiple tools that are currently available to locate the underground utilities. I will explain how this new technology will fill some of the gaps which the traditional technologies cannot be able to provide the data. I'll try to highlight some of the benefits of this new technology. And more importantly, I'll be focusing most of my presentation talking about the bridge replacement project BR3-437 on SR54 to locate the underground utilities which are going under the water. And again, I'll be explaining the results for the Artesian water utility and also the Sussex County forced sewer sanitary pipeline. So again, we'll take an opportunity to express some of the lessons that has been learned on this project, both from the right-of-way owner perspective and also the utility owners. And then we will open for Q&A to address some of the questions from the audience. And then we'll conclude with the Department of Transportation, the DelDOT team, with their feedback and conclusions on the results that has been provided to the team and how they have utilized this data and try to be more proactive and address their needs for the bridge replacement project. Before getting into the details, I would like to connect some of the dots. The DelDOT Utility Summit 2022 was a huge success. There was a good participation from cross-functional members, from the utility owners, the contractors, and multiple teams were kind of participated in it. And one of the slide, and again, there was a survey that was conducted where it has been given opportunity for the participant to express their voice. What are the things that they will be interested to know from these kind of sessions? So there was a good response from multiple people. Again, you can see each of those individuals who wants to learn more new things. And Again, what we will be focusing on this presentation is all about the technology, and which was one of the voice of the participants from the previous summit. So we will be addressing the technology, and we will be talking about some of the projects that Del Dot was working on. How can we promote the damage prevention? How can we reduce the damage and pipeline hits during the infrastructure projects? And also the key is the utility coordination. So the Delta team is kind of very actively working with the utility owners, which is very key to know where the utilities are before we get into the field. And again, what's the implementation plan, and also who is accountable for what. Again, the utility owners are responsible for their utilities. And again, if those as-built maps are provided back to the Delta team, then the team can be successful to get the project done without any surprises. So who should be accountable for what? So as-built maps is more the responsibility for the utility owners. And here we're going to talk about how we coordinated with these multiple people and to get the viable data to make some decisions. And I would like to take the opportunity for all the presenters of this presentation to express what were the lessons learned from this project, which is what will be valuable for the upcoming projects. So we will conclude our presentation with the lessons learned from each perspective, like from utility owners' perspective, what are the lessons that they have learned through this project, and also what are the lessons from the Del project, how this all has been coordinated, and also lessons learned from our technology perspective. What are the things that we can improve for the future projects? So without taking any further time, I would like to jump into the technical details. And again, this is a collaborative presentation by Prisum Technologies and Inframap. Again, I would like to give a quick introduction about Inframap. Inframap is a underground utility investigation. Again, apologize. The Prism Technologies is a division of Context, not Inframap. Inframap is a completely individual entity by itself. Apologize for that correction, that mistake there. So the 3D gyro mapping technology, again, the more important thing is we need to have a reliable as-built map to make any decisions in the field for the bridge replacement or any other utility that's being installed. They need to know where the current utilities are. This is my favorite slide. So every utility owner know where their utilities are. They have a good understanding about their asset management, but once you open the ground, it's so much of congestion there that utilities are so close to each other. And if you don't know where these existing utilities are, there is a high possibility of cross boring. And again, cross boring a gas line is a very, very catastrophic. And again, not only the gas line, but any utility that is going underground, if it is being cross bored by the other utility or because of the other construction that were happening, it's not only the safety issue. Again, it's very important. Safety is very important. But other than that, there is going to be a service interruption and a lot of project delays, cost overruns. So it's very important for everyone to be very proactive to know where the utilities are so that the people who are trying to come up with this new infrastructure builds can complete the projects on time without any surprises. So most of the utilities, when they get into the ground, even before they get into the ground, there is going to be a construction, there is going to be a design phase where the as-plan maps are generated. And again, these as-plan maps are generated by the engineering group of people, which is called as an as-plan map. But once the contractor hits the ground, or either boring or open trenching, then he will be running into multiple roadblocks. Like probably there is a rock, so he has to steer his HDD away from the rock and then keep moving. But all these critical modifications or the changes that has been made by the contractor need to be captured onto an as-built map. So there is a definitely huge need to have an as-built map generated after the pipe is put into the ground. And these as-built maps are very reliable. And again, if someone is building a new project in future, and if he's referring back to the as-planned map, which were design-based maps, then there's going to be a possibility that they may run into problems. So all the GIS systems that the utility owners own should be populated with an accurate and reliable as-built maps, which will be helpful for the future projects. You might be surprised, there is an there is all traditional systems that's already existing. So person can walk over or have a sound in the pipe or tone the pipes or have a tracer wire. We can locate those utilities, and absolutely right. We can use all the technologies like above ground tracing to locate the underground utilities. But there is a gap. Like, what about if you couldn't able to locate an above with the above ground services, like with the EMI, electromagnetic induction? What if the pipe is going under a river? We cannot do any above ground locating. So that's where we add value with this technology. If the utilities are unlocatable, like for example, HDPE, PVC, there is no tracer wire, then we may not be able to locate them. And again, if it's an abandoned line, no one have a good as-built map where those abandoned lines are. And again, as I said, no traceability for the pipes. There is no ball markers or traceable wire, or if the utilities uh, are unlocatable, non-metallic pipes. Those are the scenarios. And again, if it's a HDD bore, HDD bores may vary from anywhere from 6 feet down, anywhere from 3 feet down to 30 feet down, or maybe 100 feet down if it's going under the water. So all these utilities that's been highlighted on the screen there, those need to be accurately located with other technologies. The traditional methods may not be able to provide a reliable data. So that's where we add value with the new technology called as gyro mapping solutions. Again, before I get any further, there are multiple terms that's are in the industry. Some of them call these technologies as inertial navigation technology. Some of them say it's a gyro mapping solutions, and the other people say it's a IMU or inertial measuring unit. Whatever the term is, the principle of functionality is same. Basically, the tool that's built with the gyros run through the system and collect the data. Again, as I explained to you in the previous slide, why do we need this technology? And again, there is a gap. There's a gap where some of the utilities cannot be located. So, for example, HDD bores or trenchless methods that's been used, we cannot locate those. So IMU technology is becoming more like a solution to map those utilities. And again, if you're talking about what exactly it does, the IMU measures the angular rate of change of its core axis. So when the tool is running through the pipe, it is collecting the angular rate of change. And then again, it's collecting 100 samples per second. So that's a very precise data that will be utilized to generate the as-built maps. And again, as I mentioned, what's a value that we are bringing to the industry is some of the utilities that are inaccessible, where you cannot access from the above ground, where there are deeper utilities. The traditional technology will have limitations to locate those utilities. So that's where we add value. And again, I want to explain what exactly happens with this operation. You can see the picture there. The tool is built with the odometers, which is collecting the distance, which is riding on the ID of the pipe and collecting the distance. And the tool is built with the gyroscopes and magnetometers and inclinometers, which is collecting the rolling, heading, and pitching information. So this is the raw data that's been collected by the tool when it is run from point A to point B, collecting 100 samples every second. And that's where the high definition data comes in for our team, the Prisum Technologies, to take the data and process it and generate GPS coordinate every 1 feet. So you'll be having a GPS coordinate every 1 feet. Again, it may not be needed for the utilities like sewer pipelines or water utilities, but when it comes to the gas industry, they want to have a very high definition data so that they can protect their utilities. Again, there are the overall process is split into two parts. The first part is using the hardware, the picture that you're seeing on the left corner. Those are the series of tools that will be put into the pipe and collect the data depending on the ID of the pipe. So the tools anywhere ranging from 1.25 inches to 30 inches can be mapped. So this is this is the step one in the process where the field data is collected. So you launch the tool on one end of the pipe and collect it from the other side. And once you process the data, then you should be able to see the results that you're seeing on the right side picture. So you'll be able to see the X, Y, Z, the easting, northing, and elevation information. Uh, Elevation information once you process the data. So if the two access points are 5,000 feet apart, you don't really need any above ground access. You launch the tool at one point and collect the tool from the other side, and that's all. You don't really need any above ground access. And we could able to generate an accurate XYZ information. So along with this XYZ information, each utility also see this data from the other perspective. Like XYZ is always important for the asset management team to establish the GIS information. Whereas if it's a gravity sewer, they need to know what the azimuth and pitch information so that they can make an assessment or a QA/QC verification to make sure the HDD contractor has maintained the proper change in grade elevation to make it more like a gravity flow. And also when you're trying to put a telecom line, you need to know what the bend radius of the pipe, because there's a possibilities that they're going to put a huge amount of glass into these pipes. And if that pipe is having a very tight bends, then you're going to just break the glass. So the telecom industry and the power industry wants to know the 3D and the 2D bend radius of these utilities. So there is a multiple ways that the people look at this data. It's not only an as-built map, it's not only an XYZ, but there are other benefits that could be utilized for making the right decisions in the field. So once you run the tool, then you take the tool, connect it to your laptop, give the entrance and the exit GPS coordinates in the northing, easting elevation. And once you process the data, then you should be able to see the aerial, the plan and the profile view, the XY, and also the depth information. And also you should be getting a 3D model to rotate and see from every angle which will be the point of the interest. So these are the results that will be outputted. And along with this, we will be providing a CSV file, because depending on what the software system that you're using, maybe if you're using a MicroStation, it's an open platform data that comes out from this software, which could be uploaded seamlessly into any GIS system. So there will be a CSV format, there will be a KML file, KML or KMZ, Google Earth file to make sure that the data is aligned to the geography. And also we provide an AutoCAD script files to generate the as-built maps. So these are all the output file that comes out from the tool. And again, this is good. It provides you the data, but the big question is what accuracy that this technology can provide. And again, we make sure once we send the tool, once we ship the tool out, those are calibrated to a higher frequency. We put it on a robotic machine to make sure that the sensors are set to a promised accuracy. So there are two systems here. One is fiber optic gyros, and the other one is a MEMS system. The fiber optic gyros, after the calibration testing on the laboratory, they are capable of generating an accuracy of 6 inches in XY over 5,000 feet, and also generate 4 inches in accuracy in Z over the 5,000 feet of length. So this is a very sensitive tool, and we need to provide an accuracy at that level. And there are other systems called as MEMS system, which are primarily used for the shorter lengths and still produce the 6 inches in XY and 4 inches in Z. So these are the calibrated accuracies from the laboratory. Again, if you ask me, if the data what we collected will be 6 inches of accuracy, maybe or maybe not. And again, there is one additional parameter that dials into the equation: the conditions of the pipe. If the pipe has water, or if the pipe has dirt, or if there is any other additional parameters that may affect an level of accuracy of this tool. But we promise that the tools that ships out from our facility are calibrated to the accuracies that's been shown on the screen here. Let me talk a little bit more into the benefits of this tool. Again, as I mentioned earlier, any utility that's going underground, whether it is a sewer, drinking water, power lines, telecommunication, gas, and oil, anything that's going underground, we have the ability to put this tool into the pipe and collect the data. Again, the tool, whether the technology is completely independent of material of the pipe, whether it is locatable metallic pipes or unlocatable HDPE, PVC, or even concrete pipes, we can still be able to collect the data. So it's completely independent of material of the pipe. As I mentioned earlier, there is no above ground tracing needed. So there is no traffic disruption that could be caused using this technology. So basically, we need an access of 6 by 6 feet on the manhole on one side and a 6 by 6 feet on the other side. And rest of it, we doesn't even need any access. So that could be 1,000 feet apart or 5,000 feet apart. We don't need any above ground access. And the depth, as I mentioned, this is a autonomous tool. It's not communicating anything with the satellite. All the data that's been collected is stored within the memory on the tool. So there is no tether or no communication with the satellite. So that being said, whether the utilities are 6 feet below or 100 feet below, the data that will be produced by this technology is highly reliable. And the reason why we say highly reliable is if someone is walking above ground, he's going to collect a point every 50 feet or 100 feet or even 25 feet and manually connect those points. Whereas with the gyro mapping system, everything is automated. You don't really need above ground tracing, and we are able to generate a GPS coordinate every 1 feet. So if you are giving that high frequency data, then we won't be missing any critical bends in the pipe. Whereas if someone is connecting the points, it's going to be a straight line. So in that process, you might be sorry, you might be missing some of those undulations. Electromagnetic interference. So for example, if there is a gas utility which is located right next to a power line, and if someone is trying to scan from above ground, there is going to be a lot of electromagnetic noise, which will be affecting the end results. Whereas the gyro mapping system, there is no components that will be impacted by the neighboring power utility. So it's completely independent. The data is highly reliable. And as I mentioned, the data is an open platform data. It could be integrated into any GIS system with a very minimal changes. And eventually, we will be producing an auditing reports at the end of the project, where you will be having the complete understanding how these utilities installed, and not only the as-built maps, but we also provide the field pictures, and we will provide some of the feedback on how these utilities installed. Or one of the thing is what have probably I'll discuss in the next few slides that there were some surprises that we ran into when we were mapping one of the utility. So all those details, it's not going to be in contractor's mind. It will be captured into this documentation. If someone is opening this document 5 years from now, he will be having a full understanding how this utility is constructed and what the conditions of the pipe is. So that concludes my technical presentation. I'll be spending more time on walking through the results of the project, the bridge replacement project, and the utility investigation using the gyro mapping tool. The first one is the 16-inch HDPE artesian water utility from the houseway from one island to the other island. You can see the west side. This is where the tool is launched. And the other side is where the tool is retrieved. So okay, and again there are some pictures. So the one thing that on this project is it's a pressurized water main, and we cannot launch the tool into a pressurized water main, though the tool is designed to operate both in dry and wet conditions. In order for us to maintain the high level of accuracy, it's preferred to de-water the water main and then launch the tool. So you can see the picture on the top right, the digging down to the utility, daylighting the water utility, and then the other group of people came behind them and then used their system to de-water the pipe. And once it is dewatered, then the utility survey team collects the GPS coordinates on the either side. And then you can see the bottom leftmost picture, the gyroscopic mapping tool, which has been used to run from one end to the other end. You can see the picture on the right where they were launching the tool with the mule tape on either side of the pipe. So there was a lot of coordination that has happened through this project. And once we run the tool, this is what the results are. Again, this is all the data that's been collected uh, is uh, GIS data. It's northing, easting, and elevation, and also we can convert the data into lat long information. We never tie this data into a topography. Like every time we give the elevation, which is mean sea level. So even if someone is coming 5 years from now, the data is still accurate. If you are trying to give the depth for the utility today, with respect to the top surface, which is a temporary topography. Someone may come grade the surface or maybe put a new pavement or maybe change that's already always a temporary reference, and we don't want to do this. We always want to tie the data to a global reference, and this is all the results for the first utility, the 16-inch artesian pipeline. The picture that you're seeing on the left is northing and easting, which is an XYZ information, and the information on the right is the elevation versus the easting. Again, this is with a scaling of 1:1. I will be showing a more detailed depth information. So this is not 1:1. This is basically 60 feet on y-axis and 1,500 feet on x-axis. So this is more like a zoomed in version so that we can get an understanding how exactly this utility is bored under the water bed. So you can see the overall change in elevation is close to 53 to 55 feet. And you can see from one end to the other end. And this is the 3D model where you can rotate it and try to see it from multiple angles. So this is viewed through the software. And again, do you really need 3D? Because the 3D modeling, the digitalization of the utilities, it's not only XY is critical, it's the depth information is very important. Having this 3D models built into the system will enable us to utilize the powerful tools like augmented reality. Again, those are very powerful tools only when you have the high accurate data. So 3D modeling will become a more requirement in near future. So it's better to be more proactive to start working towards that goal. Um, this is from the aerial view. Again, you can see there are two pins, one on the west and on the other one is on the east. The survey grade GNSS tools are utilized by the Inframap to collect the GPS coordinates on either side. And again, this is a sub-centimeter addition GNSS tools that's been used to get this data. This is very critical for this process because if this data is off by 5 feet, then all the GPS coordinate that we will be generating between these two boundary conditions will be off by 5 feet. So it's more important for us to get this high accurate GPS coordinate. And again, it's not difficult. There was a lot of democratization happened in GNSS world. There are very powerful tools which can generate a high accurate GPS coordinates. So once this GPS coordinates is collected, then we put the tool in the pipe and process all the data with this known GPS coordinate. Once we process the data, then that's where you see the XYZ, the profile of the pipe, the plan and profile of the pipe. The red line is the result of the 3D gyro mapping system. So as I mentioned, we not only provide the KML file, again, all the utilities are already well established with their GIS system. So we will be able to provide them the data in the CSV format that you are seeing on the screen. And also we provide the shapefile, which is a very easy integration into their GIS system. So there are multiple formats like CSV, the KML, the AutoCAD script file, and the shape file for the GIS engineers. So the other thing, again, QA/QC, right? Okay, we got the data, but what's the level of confidence on this data? So Inframap has utilized their soft digging, the vacuum excavation. And again, they cannot excavate anything on the water, but they did found few spots where they went and used the vac excavation, and they collected the, you can see the green pins. The green pins are the soft digging test holes uh, where they daylighted the utility. And the red line is what the GIS mapping data from the Gyro mapping tool. So you can see there's a lot of um, coincidence with the test holes and also the data that's generated by the Gyro mapping tool. So that concludes the first part of the presentation. The first part of the presentation, which is artesian utilities. And then now we get into the other side, which is the 8-inch forced main sanitary sewer pipeline. So here, again, I will let Mark also to pitch some of the lessons that we have learned. It's an 8-inch pipe. We were using a very similar tool that's been used on the water utility. And again, we always make sure that we don't use the same tool on the multiple utilities. We always have the sewer mapping tools separate and the water main mapping tools separate. So we have a second DR4, which we plan to use in this sewer pipeline. And after running like 510 feet, then the tool was not able to move any further. And we didn't really had any understanding what was happening. The tool has a set amount of expansion when it is in the pipe, because it's a spring-loaded pipe. The odometers will be touching the ID of the pipe. But what happened here is you can see that the picture in the middle, a 6 feet segment was not lined. There was no liner on the pipe. So the diameter of the pipe was much, much higher than the ID of the lined pipe. So there is a, so what happened was once it got into the 6 feet section, then the centralizers on the mapping tool expanded. And when we were trying to pull it out of that segment, then it was not contracting. So there is a level of contraction that can be accommodated by the tool. But if there is a change in, there is a significant change in the ID of the pipe, then the tool will get lost. So we didn't really had any understanding that there was a segment of the pipe that was not lined. If we had that a level of understanding, we would have used another tool, which we have used it after we ran into this problem. But the team was the Del team and the Sussex County team was having their team members, because once the tool got locked, then they got the excavation, dig down. Until we dig down, we didn't really had an understanding what was going wrong. But when we took that piece of section out, then the diameter of the ID of the pipe was significant amount where the tool was not able to collaborate. But we were able to retrieve the tool. Then we made the decision to change the tool. Instead of pulling the tool, we are pushing the tool using a fiberglass rod. So you can see the picture on the top. It's a fiberglass rod. And again, you can see the tool that was holding the hand. That's the smallest tool, which is 1.25 inches in diameter. So the tool doesn't have any odometers to collect the distance. The odometers are built into the pusher. The picture that you are seeing on the left bottom, that's a pneumatic pusher, which is having the odometers, which will be collecting the data. So basically, the tool that's been held in the hand will be collecting the rolling, heading, and pitching. And the pusher is collecting the distance. So we take these two data into the software and then process the data. So you can see we were using 800 feet push rod system to push it through the pneumatic pusher, and then get it to the furthest most point. And once it gets to the furthest most point, we pull it back. So basically, the system has both the directional motors, which will make the tool to push further away from the starting point and then reverse the motors and pull it back to the starting point. So once we pull the tool to the starting point, then we connect it to the laptop, process all the data, and this is how the results looks like. The picture on the left is XY data, which is northing and easting, and the picture on the right is the easting and the elevation data. And again, let's see how the elevation profile looks on the depth point of view. So you can see it's almost kind of going close to 16 feet below. I'll say 16 to 18 feet below. Probably we have more detailed information from our CSV file. So there were two runs that were done. The first run was going in the forward direction from the west to the east, and the second run is considered as a backward run, which is coming from the east to the west. So the results that's been shown on the screen is the average of these both runs, which give us a good understanding. So as I mentioned, there is also a 3D model of this utility. Uh, I'm still not 100% sure what exactly happening here. Again, it's an 8-inch pipe, so the tool is 1.25 inches. So probably it's kind of making a lot of movements in the vertical plane when it is going. So I need to connect with Mark Parker what exactly was happening at this point. But from the depth perspective, the data is reviewed with some of the information that we have from Sussex County to build more intelligence, more confidence. So you can see this is the XY information. The utility is bowing more towards the bridge. You can see there was a bowing happening towards the bridge, and this is what the depth information. And again, as I said, we provide them the CSV file to put into their system and get more better understandings. So I was again, I apologize. I was planning to be there in person to present this information because of the family emergency. I have to travel internationally to meet my family here, so I couldn't able to be there in person to present this. But the plan was to present this data in collaboration with Infomap. Infomap and Prisum Technologies has put these details together. Let me show you what was the expectation of this utility, like as planned map, and what is the true as built map. So this is an artesian utility. The red highlighted line is the as planned map. I'll say it's an as planned map based on some of the data that they had in hand. But once we run this gyro mapping tool, the accurate as built map is here. So the green line is the true representation after the HDD boring is completed. And again, if you see at this point, there's a lot of offset from the as planned map, which is close to 20 feet. But at this end, it was very accurate. But on the other side, it is very accurate. But it's just happening in the middle of the water where this offset was kind of observed. And again, we'll say this data is the data that's provided by the GIS tool is accurate because the tool is riding inside the pipe. So all the data that's provided is based on what the data collected by the tool when it is inside the pipe. Let's see how it looks on the Sussex County side. The red line is the line that's been informed how this utility is installed. And again, if this utility is installed tens of years before, basically they generate the map connecting the two manholes with a straight line, right? So you see the red line is just connecting the manhole on one end of the island to the other end of the island. It's just connected as a straight line. But when we ran our tool, this is the true representation of that water utility. And again, there is a significant offset at the bottom of the water, at the bottom of the water bed. You can see that the XY is off. Is off. So the green represents the gyro mapping system. So I'm getting close to the end of my presentation here. Again, Prisum Technologies is providing this as a service to run these gyro mapping tools. We will be able to work with your preferred vendors. We give the tool to your preferred vendors, and again, any person who can pull a rope through a pipe can be able to pull this tool through. There is no extensive training that is needed. There are some best practices you need to make sure when you're running the tool. Try to make sure that you are maintaining a consistent speed. And again, we have the electric operated and battery operated winches, which will make sure that the speed is consistent. So basically, there are very basic best practices that need to be followed. And any contractor can pull this tool through, and they will be successful getting that step one, which is the data collection. The step two is the data processing. All the data that's been collected by the tool will be uploaded to a cloud where the data is received by the data analysts, and they will process the data and be able to generate an as-built map within a matter of hours. So even before you close the field, we want to make sure that the data collected is reliable so that you can go ahead and close. So within a matter of few minutes, we should be able to tell you whether the data collected is reliable or not, so that the field contractors can go ahead and close the ground. And then our team is going to process those results to a fine tuned, and get you the accurate information. And again, as I said, we can validate or audit your as planned or as planned data with our true as built information to make sure if the contractor has done their job meeting the bid specification. So this tool is not only generate the as built map, but also considered as an auditing tool to make sure that that the bid specification is kind of maintained by the contractor. So it's not like finger pointing on anyone's work. This is primarily to give the true representation how the pipe is installed in the ground, which will be very valuable for the utility owners for their future projects. And again, the other thing is the industry is moving towards digitalization. All the data that's been collected will be uploaded into the 3D modeling using the ArcGIS ISRI systems, and also the augmented reality. The augmented reality is a very powerful tool, and those are expensive and powerful tools. And in order for us to maximize those powerful tools, we need to have an accurate as-built map. If you are trying to put an as-planned map into these powerful tools, we are just beating the purpose of those technology. So I think this is my concluding slide before I pass it on to Ken Kerr and Sean. Thank you very much for giving us an opportunity to utilize these tools and help you on reducing the damages and hits in the field. So back to you, Eric. I have the next slides for the InfraMap to go over some of their observations and lessons learned, and also lessons learned from the Sussex County and the artesian water utilities. And there is a concluding slide from the Del team, how this data is being utilized for the planning stage, and how this helped them in building a lot of confidence before they get into the field for the bridge replacement project. Thank you, Eric. I appreciate your help. And if there are any questions, I will be available, or one of our representatives will be there to answer the questions. Thank you very much.